The loss L due to a boat accident is exponential. Insurance policy A covers up to 1 unit of each loss. Insurance policy B covers up to 2 units. The probability that a loss is fully covered under policy B is 1.9 times the probability that the loss is fully covered under A. Find the variance of L. So L is the loss, it's exponential. We're not given its mean, so let M be the mean. Then we know that the CDF will be 1 minus e power negative L by M. Now the loss will be fully covered by policy A if it's less than or equal to 1, because policy A covers up to 1 unit. Similarly, it will be fully covered under policy B if it's less than or equal to 2. And we are given that the probability of being fully covered under policy B equals 1.9 times the probability that it's fully covered under policy A. So that means probability L is less than or equal to 2 equals 1.9 times the probability that L is less than or equal to 1. So at probability L less than or equal to 2 is the same as big F of 2, and L less than or equal to 1 is the same as big F of 1. We have this equation. So f of 2 is 1 minus e to the negative 2 over m, and f of 1 is 1 minus e power negative 1 over m. Now, if we let e to the negative 1 over m to be x, then this one becomes x squared. And the equation will be 1 minus x squared equals, and here I can distribute. So 1.9 times 1 is 1.9, and then 1.9 times x. So we collect everything on the right side to look at it as a quadratic equation, which we can solve. So negative x squared goes on the right as positive x squared, and then we have minus 1.9x, and then this one gets to the right and gets subtracted from 1.9 to give 0.9. And now this one factors into x minus 1 and x minus 0.9. Now, for this particular situation, these numbers were of a nature that we could have done something shorter, but I've taken a slightly longer route because this will be applicable in all situations, no matter what the numbers are. So even if it doesn't factor, then you know that at this point you can use quadratic formula. But for this particular problem, notice that this is 1 minus x squared. And if here I don't distribute, but I just write 1.9 times 1 minus x. So let me show you that step here. In fact, let's add that step. So the step prior to that was 1.9 times 1 minus x. And now you can see that this one factors into 1 minus x and 1 plus x. And then the 1 minus x factor will cancel out with this. And you will get just 1 plus x is equal to 1.9. And that's a bit shorter than what we are doing. But this is illustrative because another idea is illustrated in this way. Remember, you won't always have a 2 and a 1 here. And that's the only situation where a factor from here will cancel out with this factor. Normally, this is the situation that's going to happen. So this gives x equals 1 or x equals 0.9 after factoring. And as I said, if you don't see the factoring, you can do the quadratic formula. And at first sight, it looks, yeah, they're both viable solutions. But remember, x was e power negative 1 over m. So e power negative 1 over m is 1 or 0.9. Now, if it's equal to 1, then that means negative 1 over m equals ln 1, which is 0, but that's not possible. A fraction where the numerator is not 0 cannot be equal to 0. So therefore, we must have only the other value, e to the negative 1 over m equals 0.9. And that means -1 over m equals ln point 0.9. So m equals -1 over ln point 0.9 equals 9.49. M is the mean of the exponential. We were to find the variance, and we know that for an exponential distribution, the variance is the square of the mean. So therefore, it'd be the square of 9.49. That's 90.1. That's choice E.